Hello students, now we have already completed the laws of motion, that was dealing with the motion of the body including the cause of motion, that is the force. Now we are going to talk about gravitation. What is this word gravitation? To understand this concept, let's know some practical natures, practical things which are already happening around us. For example, have you ever wondered why moon, such a huge heavenly object, is revolving around earth, or why earth, even bigger mass, is actually revolving around sun? So how come these two such huge bodies are in a state of constant motion in effect of some force, some invisible identity due to which each motion in our solar system is happening? What is that force? That force, my friends, is gravitation. So what exactly is gravitation? Okay, so we're going to study about what exactly is gravitation. Gravitation is a force of attraction between any two bodies in this universe. Okay, it is a force of attraction between any two bodies in this entire universe. Now, what do we mean by any two bodies? For example, this marker and the camera, this marker and my mobile phone and the planet Jupiter and sun, between any two bodies, this cap and a distant star. So there is a force which is acting on between these two bodies, any two bodies, and that force is actually a force of attraction. This force is called gravitation. So gravitation is the basic force in nature which keep the motion of all the planetary things, of all heavenly bodies. So how do we know what exactly or what is the amount of this force? That was devised by Sir Newton, and that is called Newton's law of gravitation, or sometimes it is also referred as universal law of gravitation. So what is this universal law of gravitation? Okay, before that, before studying this force, you should keep this fact in mind, that the force of gravitation exists between any two bodies in this universe. Now I have already stated that this is a force of attraction. So if I say that this pen, this marker and planet Jupiter is attracting each other right now, so why don't they just come towards each other and collapse or make a hit? Why? Because yes, there exists a force of attraction, but the force is supremely small. It's highly small. That is why the force is just not observed in practically when we are talking about small bodies. But yes, in case of those big bodies, for example, very huge masses, let's talk about Earth and Moon, let's talk about Sun and Earth. In these cases, what is happening? The mass is really huge. That is why the force is appreciably observed, and that is why Earth revolves around Sun, right? So what is Newton's or universal law of gravitation? Actually, this formula which I am just about to tell you is not only the homework of Sir Newton. It was actually studied by a lot of scientists. For example, Kepler, for example, Galileo. Galileo was very famous for observing all sort of planetary motion. He kept his observatory and he always noted all the points, how planets are moving, how different stars are moving, right? And that is how all these scientists accumulated data, and somehow the formula was devised by Newton, right? So this, according to this universal law of gravitation, suppose we have two bodies of mass m1 and m2, and there is a mean distance of separation between them, which is r, then the force of attraction between these two bodies is directly proportional to product of their masses. Though what is universal law of gravitation? The force of attraction between any two body in this universe is directly proportional to product of their masses, and it is inversely proportional to square of distance between them. Now if I add these two factors, I'll get force is proportional to m1 m2 upon r square. So this is what the law of gravitation states. I'll repeat it again, you can write it down. According to universal law of gravitation, force of attraction between any two body is directly proportional to product of their masses and inversely proportional to square of distance between them. So when we accumulated these two data, we got this, that force is proportional to m1 m2 upon r square, and to remove proportionality sign we'll have to put a constant of proportionality. Now how these constants are calculated in observation or in experiments, we actually we put all these quantities here, right? R square will be multiplied, m1 m2 will be taken down, and we'll get some quantity. That quantity is taken to be k or constant. Usually constant is represented by k, but in many formulas the constant will be given some name. As in this formula, the constant will be given some name, right? So constants are actually taken out in with experiments, and the formula here becomes F is equal to the gravitational constant, which is, this is also called universal gravitational constant. This is our constant of proportionality, G, m1 m2 over r square. This is the complete formula of gravitational force. So this gravitation is this gravitational force, which is G m1 m2 upon r square, where this term G is what? This is universal gravitational and what? This is universal gravitational constant. Does this constant has some value? Yes, it has a value. What is the value? The value of G is 6.67. You won't be taking 6.67, you will be taking 6.7 for ease of multiplication. So 6.7 into 10 raised to power minus 11. What would be the SI unit? See how to find, how to not remember the SI unit, or how to not memorize or not learn, because SI units can be devised anytime. Keep G here, multiply, I missed r square, sorry. So keep G here, multiply force with r square, what will I get? What is force? It is Newton. What is r square? R is the distance. What is SI unit of distance? Meter. So here I have meter square is getting multiplied here. So Newton meter square divided by, what is here? Mass into mass. SI unit of mass is kg. So I am getting kg into kg, which is kg square, and this kg square can be taken on the denominator side. So I will be left with Newton meter square upon kg square. This is the SI unit of universal gravitational constant. Now how do we use this value? For example, let's say we have to find force between earth and moon. Okay, so how can we find the force between earth and moon? Do we know the distance between earth and moon, and do we know the distance of separation between earth and moon? Yes, we actually have all the values. Let's start from a simple example. We have to calculate